Okay, without further ado, hello and welcome to our talk on, it's a long title, please bear with me, Weaving Microservices into a Unified GraphQL Schema with GraphQuilt. Graph-Quilt here is the name of the project that we're featuring today, but the talk is in general about GraphQL orchestration, like the problem of GraphQL orchestration. And we actually have one of the maintainers of GraphQuilt here with us today, Ashpak. So Ashpak, can you introduce yourself?
Hello everyone, thanks for joining us today. My name is Ashpak Shaikh and I'm a senior staff software engineer at Intuit. I've been at Intuit for about 10 years and I've worked on apps like consumer-focused apps like TurboTax, Mint, Virtual Expert Platform, etc. Currently, I'm leading the Dynamic Experience platform team, which is responsible for creating consumer experiences. I'm a GraphQL expert at Intuit and part of the Intuit API stewardship squad, which is responsible for basically creating design guidelines for creating beautiful APIs at Intuit. I am passionate about service orchestration and domain-specific language. Built a few domain-specific language internally at Intuit. That's about it. Let's start with Lucy.
All right, thank you. And hello, I am Lucy Shen. I am a developer advocate at Intuit, formerly a software engineer, mostly working on the front end for QuickBooks Online of almost 4 years, actually, before I switched into dev advocacy. Nowadays, I work on our internal and external API programs, actually. So if you're curious about our externalized fintech APIs, come talk to me after. It's a brand new venture that we're very excited about. So, but today, we're here to talk to you about GraphQuilt specifically. On the agenda today, so actually, can I get a show of hands? Is anyone here like new to GraphQL? You're not familiar with GraphQL, exploring it as a possibility for yourself? That's actually a lot. That's a lot of you. Okay, that's good, because we're going to do a GraphQL 101 first. We wanted to make sure you guys were covered. So I am actually also pretty new to GraphQL myself. So me, a new learner, I'm going to walk you guys through a 101 level based on my current understanding. And then we're going to do a quick demo, actually a video demo from another maintainer of how GraphQuilt works to solve the GraphQuilt orchestration problem. And then Ashpak's going to take us through the orchestrator history at Intuit, actually, like the specific problem statement we have at Intuit, followed by how we actually do schema composition in like specificity. And I mean specificity, like we're going to jump from like a 101 level to 301. So hold on tight. And then we're also going to go over some of GraphQuilt's other features. It's a large library with a lot of modular components to it. So before all that, really quick, if you are not familiar with us already, we are from a company called Intuit. Intuit is a global financial technology platform. Basically, we do fintech services for consumers and also small businesses. I mentioned QuickBooks earlier. That's the product I used to work on, and Ashpak does a lot of work with TurboTax. So awesome. Let's hit the 101. Let's hit the ground running. So first of all, I think most API developers are already familiar with REST, right, in terms of just API protocols in general. So the best way to introduce GraphQL, in my opinion, is to compare it against REST. Like, why should you even consider GraphQL when we're already all using REST all over the ecosystem? The main reason is because of this diagram, actually. So imagine you're rendering the front end for a blog website, and you need to pull the posts, the comments, and the author's data to render it into the front end, right? To do that on a REST API, you would be calling 3 different endpoints to get those points of data. First, the post endpoint, then the comments endpoint, then the author's endpoint. You're going to end up with a whole bunch of metadata that you may or may not need. Maybe I don't need the date of publishing for the post or like the most recent comment. I just want to render the like listing page of all the most recent blogs, right? So I don't need all that metadata. So REST is chronically, I mean, it's known for having kind of an overfetching, underfetching problem. You have to make a lot of round trips. So that's how it's like to be a REST API developer or user. On the GraphQL side, it's this ideal solution of like, what if I only had to make one service call to get all of the data I need and nothing more in the structure that I want it in, and then just make that one service call and be done with it. This is the ideal state of GraphQL APIs. So in the diagram, you'll see that it's 3 different, it looks like 3 different endpoints. It's 3 pieces of data, but it's all going through the same GraphQL service. So that's kind of the idea, the difference on a high level. There are obviously some drawbacks. I'm not going to say GraphQL is perfect. There are some trade-offs. So there's some increased server complexity. It has some caching problems, actually, and there are also obviously compatibility limitations. For example, Intuit's own developer portal, we have it set up for REST developers. We actually do not have a way for you to onboard to our GraphQL APIs like automatically just yet. So that's just an example of the ecosystem limitations that still exist for GraphQL at the moment, because it's still pretty new. But what is GraphQL? I told you about the differences against REST, right? But when I first heard the word GraphQL, I actually thought it was a database technology. It's not. It's a query language API. That's what the QL stands for. The services for GraphQL can be written in any language. It's totally language agnostic. And it was open sourced back in 2015 by Facebook. But I would say that in the recent years, it's really started to pick up steam, and we're starting to see more widespread adoption. And Intuit is absolutely part of that trend. So, giving you a quick look at what a sample query and response looks like. Like I said earlier, what if you could make one call and just get all your data in the shape that you want it in, and all the data and nothing extra, right? So in this case, we're going to use a little Star Wars example. In my query, I am starting with a root object. That's actually an aliased query. It's called hero, name, and friends. We're going to select the hero field out of that root object, and then out of the hero object, get the name field, followed by the friends field. The friends field is another object, right? So there's a subfield there for your friends' names. And so that it returns as this sample response on the right side, which has the exact same structure as what your query was asking for, and only the data you asked for. And you'll notice it obviously supports subfields in this case, but down to like a very deep level. And there are a lot of other features. This is obviously a very simple example. But other features include fragments, arguments, aliases, variables. Actually, this is an example of an aliased query. So graphql.org has a lot of really fantastic documentation. So does the Apollo Foundation, and I highly recommend checking it out if you're new to GraphQL. So because the shape of a GraphQL query really closely matches the result, I think you can see the power of this, but I think it also naturally arises the question of like, well, then how do I know how to shape my query and what data is even available? And so that's where the schema is really important. So that's where I use the schema definition language. What is the schema definition language? Why? Of course, it is the language by which you define the schema, but that's extremely unhelpful. So let me start with what a schema is. The schema describes the shape of the available data that's on your GraphQL server. It also defines all the queries and mutations available to the client. And so there's like a hierarchy of types with fields. They're populated from the back end. It's actually pretty intuitive, to be honest. But on the right side, you can see what a sample schema looks like. I'm defining the type character, right? Following the same example as before from Star Wars. I'm basically saying here I have a non-nullable string in the name field, and then I have a non-nullable list. The appears in field after that is the non-nullable array of non-nullable episode types. An episode similarly would be defined in your schema. Underneath it, Starship is similarly, there's actually an argument there with a default value that you can see in action. So this is what a sample schema, a very small sample schema would look like. How does this all then string together into a service? You have your schema, you know what the query is probably going to look like and how the response is going to look like, but what does it mean to make a GraphQL service out of all this? So you have your schema. We're actually going to move to a fresh example here, keep you guys on your toes. We're going to go to a pet store example. So here we're defining a pet type on the left in our schema. And on the right side, we're implementing what's called the data fetchers, also known as the resolvers. These words are kind of interchangeable in the GraphQL sphere. I think Ashpak actually usually uses resolvers when he talks about this. But if you're a REST developer, the easiest way to understand this is that in REST, you would have a specification for your API and then a controller, right? So maybe you follow Open API spec. It's defining your path, your parameters. It's telling people what to expect out of your API. In the same way, your spec in this case is actually your GraphQL schema. And then instead of a controller, you have a data fetcher or a resolver, right? So it's the same exact thing. All your business logic, where it would go into the controller, instead it goes into your data fetcher and resolver. And in this example we've given you, we're actually using an open source library from Netflix called DGS, which I think anyone who's written a controller knows there's a lot of boilerplate that goes in there. So libraries like DGS help you simplify all of that. So you can just tag a few things and auto-wire everything. All right, cool. So, it all sounds really ideal. It sounds like a very blue sky solution. Wow, I only have to make one service call and only get the data I need. And that's it, that's game over. I can just, why would I ever use REST, right? Well, there are some new problems that are presented where the whole point of using GraphQL is to solve a multi-endpoint, multiple round trips, overfetching, underfetching kind of problem. But what if you had to call multiple GraphQL services? Which actually seems really obvious. Of course you're going to have to call multiple GraphQL services. In fact, you're probably going to have to call them in conjunction with some REST services because not everyone has GraphQL up and running yet. So in this case of a new multi-endpoint problem, how the heck do you, what's the point of using GraphQL then? Is there a way where I can still have that client-side experience of making a single GraphQL query, getting all the data I need, and then just not having to worry about it? Is it still possible? And so that's what we call the GraphQL orchestrator problem, which is what the rest of this talk is going to be about. So I hope we're feeling pretty comfortable about GraphQL just conceptually at this point. So in the example here that we have now, the idea of using a GraphQL orchestrator is to solve that problem of having multiple endpoints. So let's say that we actually have on the back end multiple GraphQL services in this case. But to the client, it still looks like they're only making one query and getting one result because the orchestration layer in the middle handles all of the schemas in between, stitches it all together, and hands you a neatly packaged thing of data at the end, right? That's the solution, but the how of it, what does it actually look like? That's what GraphQuilt, the project that we're here to present, solves specifically. So I'm going to give you a quick demo. Actually, not me. One of our other maintainers is going, that is me, but one of the other maintainers is going to give you the demo. This is actually a clip out of a longer video we have introducing GraphQuilt, and actually with a quick getting started guide and some sample code in it that if you want to play with it, it's all available on the GitHub, and you can watch the video to get a walkthrough, basically. But if you go to the Intuit developers YouTube channel, you'll find the full video. I'm only going to play the demo section here, so I'm going to go ahead and hit play. And sorry, the audio's a little janky, so we're just going to...
First tab, so this is the person name service. So it was a
I forgot to explain. So really quick first, this user interface looking thing that, this is Carlo over here, by the way, one of our maintainers. Carlo is using something called GraphQL here, which is an IDE actually for GraphQL. You can set it up against your local version of your GraphQL service and run test queries against it. So it's just a good way to like develop your GraphQL service and test that it's giving what you expect it to. So we're just going to keep going.
person type, and it includes the first name and last name fields. You can also run query against them. So yeah, person. And then you can query the first name and the last name. And running this query should give you this result. So Tony's start. For the second service, it also has a person as a top level field, and it only has the address field. And if you query this, so you have the person as the top level, and then address, and then it has city, state, and the zip. So if you run, so it will give you just the city, state, and zip. So the person address service doesn't have the first name and last name fields. So it will be an error if you try to query that one. For the third service, this is the GraphQL. So you can see that the person is combined in this service. So here you can see the person type has field name, last name, and the address. And you can query them. So what the GraphQL orchestrator library does, so if it receives this query, so you have the first name, last name, and address, so it splits that query and calls the appropriate downstream services. So in this case, first name and last name goes to the person service, and the address goes to the person address service, and then combines the result afterwards.
Awesome. So I hope that was pretty clear in the demo. This is the end result. This is what it looks like after you've implemented the GraphQuilt orchestrator, what it looks like to combine two different services together so that you only have to make one query to get data from both. So from here, I'm going to pass it on to Ashpak, who's going to, who's going to talk about how we got to the solution and how it works, actually.
Thanks, Lucy. That was awesome. So I'll talk about a brief history of how the orchestrator evolved at Intuit and my personal journey going through that, going through implementing the orchestrator. Before that, I'll just quickly walk through the numbers that we have currently. This is the numbers that we have in production. We have almost 54 subgraphs or services registered with our orchestrator. We have 150 clients, mobile apps, widgets, backend services which are querying the orchestrator. We have gone through this orchestrator for 4 tax seasons with almost a TPS of 5,000. Some of them are REST services registered. I'll talk about what REST adapters are. And we have authorization implemented. The overhead that the orchestrator adds when you make the downstream call is just 6 milliseconds. So it's highly performant and scales to the numbers that you're seeing on screen. So quickly to iterate the problem in the context what we had, right, back in 2017, 2018, we were coming up with the idea of an app which will take data from the tax ecosystem and the credit ecosystem and show a better financial picture to the user by showing metrics like net worth, debt to income ratio, and stuff like that. Now, GraphQL was chosen here because the tax return is a very huge document, almost 50 MB, because it has lots of forms and forms. Similarly, the credit report is also a huge document. But for to calculate the debt to income in this example, you only need the income from your tax return and the debt from your credit report. So we wanted to avoid the overfetching problem, and GraphQL just fit right in, right? But the problem is that these two are different services, and we need to get data at once to get the complete benefit of GraphQL. Now, with that problem, I just want to, with this screen, I want to clarify the terminology that I'll be using. For GraphQL orchestrator, we use the terms as supergraph or GraphQL gateway or the orchestrator itself. And for the microservices that are registered, we use the term subgraph. I might use the term providers, but it means the same. So now with that, when we had that problem, we already had an existing orchestrator, and this is how a high-level registration process looked like in the existing orchestrator called Platform Abstraction Service. We had a central repository which was defining schema in YAML, not GraphQL, and then that schema got packaged into a jar, which is a schema jar. Then the jar gets introduced into the microservice or the Spring app that you have. At that point, you can now wire the resolver that Lucy was showing in the microservice and be ready for creating GraphQL APIs. Then you need to take the same schema jar and the SDK in the supergraph as well, and then the supergraph will be able to serve the updated schema. Now, there are a few problems here. There's a lot of coordination and sequencing required for the teams to actually get their schema to the supergraph, right? The authoring was done in YAML, so it was not pure GraphQL. So getting up to date with the schema, the GraphQL spec was becoming difficult. There was a hard dependencies on the compatibility of SDK versions for the supergraph and the subgraph. So that made debugging difficult, and actually upgrading the library is also very difficult. So then we had another experience in the TurboTax Live ecosystem where we were creating a GraphQL gateway with a multi-module project. So every schema and resolver is its own GitHub repository. It is also packaged as jar, but then it is combined into a single executable into a multi-module project. The big important learning here was the schema was authored in GraphQL, and we were using GraphQL Java libraries to create the resolvers, not the custom that we built internally. And the developers were very happy doing that, because GraphQL has a lot of documentation, a lot of resources outside to help, and people were like almost self-serve. But soon this started increasing, the number of modules started increasing, and this also resulted into a lot of coordination and sequencing that is required to go forward with the release of the gateway. The gateway becomes a monolith at this point, right? So we decided to create our own, like 1 year into this journey or 1.5 years into this journey, we decided to create our own orchestrator. And then we raised these concerns with the leadership, and we got a mission team approved to work on a GraphQL orchestrator at Intuit consumer group. The goal was to just merge two services, tax and credit, a very modest goal. But the vision was to create a single endpoint for all things data fetching and make sure it scales to a ecosystem that we have at Intuit. So with the learnings that we had from the previous two orchestrator, we created a solid set of first principles. This might help for anyone who is creating or just embarking on that GraphQL journey. The first is on the execution principle. We need to use the GraphQL specification and not any customization to the spec for schema authoring. The schema authoring needs to be in SDL. And the subgraph and supergraph communication needs to be also in GraphQL. So in the past example, the communication between the supergraph and the subgraph happened using a custom prepared query spec, which was not GraphQL, which made debugging very difficult. Because imagine the incoming query is GraphQL, but the outgoing query from the orchestrator is not GraphQL. So it makes triaging difficult, and there's a lot of translation, right? And the orchestrator should be like a proxy. Whatever query it comes, for the subgraph, it should just forward the query if it belongs to that subgraph. The second was registration, and this is very important because this will make you scale at the level if you have a lot of microservice and teams developing their GraphQL services. It needs to be loosely coupled so that the subgraph and supergraph can have independent life cycles. Like supergraphs can just build their own service at their own pace, and the subgraph can do their own pace, right? So I want to just quickly talk about the registration that we do at Intuit and how it scales. We have a very simple registration mechanism, and we do it via a register endpoint in the orchestrator. In addition to the GraphQL endpoint, there's a register endpoint. Whenever a subgraph is starting up, we have implemented a registration library which at startup will call that register endpoint, pass in the schema and configuration files to the orchestrator. The orchestrator has a copy of the schema that it is serving, right, for the live traffic. So it will validate these files against the live schema and see if the schema from the subgraph is composable or not. If it is not, it will just error out to the subgraph, and the subgraph will not start up. It will be a very early quick feedback to the subgraph developer. Once it is successful, we persist the files to S3, where other instances of the orchestrator is already listening, and it will refresh their schema dynamically. So this is a sequence diagram in the nutshell. Basically, the orchestrator instances also validate, and it also is listening to S3 to refresh its schema. So this dynamism is very important because that helps us make sure that the orchestrator and the subgraph are independent of each other. So these are the set of files. One is a schema.graphqls file, which is the shape of the shape of the query that your service can accept, and the other is a routing configuration file, which is the config.json, which has information about where to call, where is your service hosted, and what is the namespace and what is the type of the service. So very simple. These are the files that the subgraph sends to the supergraph while registering. Now. Type name conflicts. It's an important concept. In a GraphQL executable schema, into a single executable schema, you can't have types which two types with the same name. So now imagine this at the scale of the orchestrator on number of microservices which are developing independently. It's very easy to get into type conflicts. An example would be the same tax and credit subgraph. Let's imagine that the credit subgraph is already registered with the orchestrator with a type profile. Now there's a tax subgraph coming with the same type profile. It is an error at that point. The tax subgraph can simply change their type to tax profile to something else, but there is already an app which is calling the tax subgraph independently of the orchestrator with the type profile in their fragments, right? So at that point, it is not easy for them to just replace that, rename the type. So we support a special directive in the orchestrator called as the rename directive, which while registration, the subgraph can tell the orchestrator, okay, I will keep my type profile in my schema, but when I'm registering, you have to rename it to tax profile and replace all the references to tax profile, right? What this helps is the clients can query the orchestrator with the tax profile type. The orchestrator will understand, okay, there's a mapping and there's the subgraph has asked you to rename the profile to tax profile, and while forwarding the fragment to the tax subgraph, it will change the tax profile to profile. So it will work both ways. So the clients of the subgraph which are directly calling the subgraph will work, and the clients via the orchestrator will also work. This is a way to have type conflict resolution, but we over the years realized that having proper schema governance goes a long way. If you start with having a governance team in place which is reviewing the schema when the subgraph is starting up, it will catch these type conflicts, and you can have proper naming convention and name spacing for the types right from the beginning, which will help you prevent these type conflicts at runtime or when the subgraph is registering. So now I want to dive into some of the schema composition use cases that we have. Now, what is schema composition? Now, the number of subgraphs when we adopt GraphQL started growing organically. Like the client started requesting, okay, I want more and more services behind GraphQL. There started, there came up relationships between the subgraph schemas itself. Like you have in database tables, there are relations between the microservices themselves, right? There were a lot of literature back in, I think, 2018, 2017, which had solved schema composition in different styles. Some of them were schema stitching, federation, and there were other libraries too. Right. So we do support a few styles of schema composition. One of them is recursive merge. I'll explain this with an example. Consider a user subgraph which is giving details about the user's personal info. The second subgraph is tax subgraph, which is giving the details about user's tax info. And the third one is the credit subgraph, like we are seeing in other examples, right? If you carefully see this, the user type has a financial info common, the field finance common in tax and credit subgraph, and the user type itself is common between all the three queries. So what recursive merge does is go start from the query, and it will go on merging the types recursively. It's like a classic tree merge algorithm, and it will create the final schema which has the user financial info and the personal info under the type user. From a client perspective, it's abstracted. The client can just see, the client only sees the unified schema. It makes a single query to the orchestrator and all works. The other type of schema composition use case is like actual relationship between the types that belong to the different subgraphs. So in this example, there's a tax subgraph which gives details about the tax info. If you see that it takes an argument year and gives list of tax info, but that is just returning tax ID and tax year. It does not have any details about the documents or the forms that the tax documents have, right? So now that is coming from the other service. If you see the other services query, there's a tax document which takes an ID and a year, and it gives a tax document. There's a query that does that. So how do you actually link these two so that the client can make the single query? If you see, we have something called as a resolver directive, wherein you can say that I want to extend the tax info type with the tax document field, but the resolver for that field is coming from a different service. The field is tax document, and I will pass in the ID and the tax year as the argument to that thing. So at runtime, the orchestrator understands this, and for resolving that particular field, it will call this tax document service, right? And it will sequence. So tax subgraph will be called first, and the tax document will be called later on. The unified schema, again, from the client perspective, is abstracted about this relationship, and the client can make a single query and get all the details in one go, right? The other thing, like when we were like just the ecosystem was maturing is outside of the Intuit and the open source community. Apollo Federation, which is a key player in the GraphQL community, came up with the Apollo Federation spec. And the same example that we saw about the tax info and the tax document service can be done with the Apollo Federation spec. If you see, tax info has to be defined as @key, where it allows anyone to extend that type and add more fields. And how to extend that is they have to define the same key in the other subgraph as well, and add the field and mark the tax ID and year as external, meaning that is not something that I own. I only own tax document in this. The result is the same. The unified schema in both examples are same. The query that the client makes is also same, but it's just to show that we support both the flavors of the spec. The first one was called schema stitching, and this is federation. We also have use cases where there are legacy services which are not on federation yet. So there are cases where we are stitching type 1 with type 2 using the resolver spec, and type 2 and type 3 with federation spec. So there's a mix and match already happening, which helps us have legacy services also participate in the ecosystem. Also, I wanted to add, like, all these things are batch. So all the schema composition use cases you see you saw are all batch. So every time there's only one query that goes out from the orchestrator to a given subgraph, and we handle all this list and arrays at the orchestrator itself. So the other feature that we have is GraphQL authorization. This is not limited to orchestrator itself, but it can be applied to an individual microservice as well. But the orchestrator problem is basically, authorization problem is you have a single endpoint. With REST, a resource is represented by an endpoint or a path, right? So, and a lot of ecosystem is available, a lot of tools are available to apply policies around the URL or path, right? So REST authorization mechanism is quite mature. But those are not applicable for GraphQL because of single endpoint model. Everything is schema, the resources are represented by a schema. So at the orchestrator, we have a central ODZ enforcement, but that does not mean that you can only use it at the orchestrator. You can use it at the individual subgraph level also. So this is how we enforce it at the orchestrator. We have a Git repo which has a ODZ rules, which is a query that a client has access to. It's a glorified map of what the details about the client are and the query that the client has access to. And we have created a process around this. Whenever a client wants to access something from the orchestrator which it does not have access to, it creates a GitHub PR which is validated at the PR step itself and approved by the subgraph developer. So both the client and the subgraph are participating here. It's an orchestrator itself for the developers. And then once the validation is done, like the rules are valid against the orchestrator schema, it gets uploaded to S3. And like the registration, the orchestrator is also listening for the rules. So the orchestrator does not restart, it automatically refreshes its ODZ rules, and that gets taken care of. Now at runtime, whenever the client gives a query which it does not have access to, we are using this authorization library, GraphQL authorization Java library, which is based on the instrumentation concept of GraphQL Java. It takes in the query, incoming query and the rules, and redacts the query so that the actual query being executed is a shorter one, only which is clean and for which the access is allowed. The advantage of doing this is basically if a query is not, if a credit query subgraph is not even allowed access, it won't call that service and you save a network hub. This is an this authorization is a very generic authorization that applies to all the subgraph. That's why it's the central layer. We have fine-grained and very domain-specific authorization at the subgraph level also. The subgraph is responsible for doing that. The other thing that we have is the REST adapter. Now, when we scale, we realize that, okay, clients just love GraphQL. They want everything to be behind GraphQL and they want only single endpoint. They don't want to do point-to-point communication. But the services are, let's say in maintenance mode, they are not ready. They don't have enough resources to convert to GraphQL. So we provide a thin layer of a concept called as a REST adapter, which takes the projection which takes the response from the REST services and applies the GraphQL schema projection and tries to match that. We have the similar pipeline like you saw for ODZ, S3 based, for REST adapter as well, and the orchestrator will automatically and dynamically refresh it without restart. So the only additional file that we require from the REST ecosystem, in the REST ecosystem, is the type changes to REST in the config.json. There is a specific DSL file, which is the specification file that you need to specify. It can, this is the DSL because this is very popular at Intuit. We have this DSL being used in a lot of places internally. So we came up with this specification. We've open sourced this DSL as well, where it can just take the GraphQL. If you see the ID argument, it takes in the argument from the GraphQL schema, and the incoming query, when it comes, it will match it to the path param. And you can do any such transformations and translate the GraphQL arguments to the REST arguments. So that's how it helps, and it's very dynamic and it's a declarative thing. So that's why we were able to achieve the dynamism that we are seeing. That's about it. To summarize, this is the simplified architecture that helps us scale over the period of 4 years with the numbers that you saw. We have a GraphQL orchestrator sitting in between the microservices, REST or GraphQL. The REST services use something called as adapter, and we have an ODZ in like central ODZ enforced at the GraphQL level itself, the orchestrator level itself, which helps as preventing illegal access and allowing fine-grained access. We use AWS S3 for saving our files, schema files, registration files, adapter files, and that's basically it, right? Now, you can find this project under the graph-quilt org. It's an Intuit open source. There is a sample gateway which has that everything in once. It has the authorization library, orchestrator library, and the adapter library. It all uses the open source GraphQL Java library, which is very popular, and all GraphQL Java services uses this library behind the scenes. Whatever wrapper you use, it uses that same library. We are actively maintaining this and participating in the Hacktober Fest. Lucy can talk more about the Hacktober Fest.
Yes, actually, really quick before Hacktoberfest, if you do scan this and go to the GraphQuilt library, you'll find that Carlo, the guy who presented earlier in the video clip, put up for me actually some example subgraphs. So if even I can follow it as a total GraphQL beginner, you all will be fine. The beauty of GraphQuilt really is that it's a collection of modular features, right? So whether you need the orchestration piece or just the registration or just the REST adapter, right? You can just grab the pieces you need and make it work for your own services. So I just wanted to make a call out and a shout out for Carlo for doing that for me on a busy day. So do check that out. In the meantime, if you noticed this beautiful shirt that Ashpak is modeling for us, and also I actually have last year's shirt on, but Intuit does participate in Hacktoberfest every year, actually, since 2019, I want to say. So this should be our 5th year, maybe 4th year participating. And so if you want to win one of these shirts, all you have to do is make a contribution to any Intuit repository, and then on the root level of the Intuit open source organization on GitHub, you will find a submission link where you just let us know where your mailing address is so we can send you a shirt in thanks for your work. And actually, just a fun fact, internally at Intuit, what we've been doing is encouraging anyone to contribute anywhere. So if you guys are tagging your own Hacktoberfest issues, you may find Intuit engineers contributing to your projects.